having done those problems and seeing how we expand those out, it showed us what the answers are for each of these. What we're going to be doing today is looking at how do I go backwards through these. So how do I go from that expanded form into factored form? And we're going to be able to do that for each of these when just given the quadratic in expanded form. We're going to be able to factor it. So take a look at the numbers that are involved. We'll use this first one as the example. So what do the 8 and the 15 have to do with the 3 and the 5? Yeah, you'll notice that the 8 comes from adding the 3 and the 5. The 15 came from multiplying the 3 and the 5. Does the same pattern hold for the other problems? Like this -9. Does the same pattern work there? Is that -7 plus the -2? Yeah. And -7 times -2, is that 14? Yes. And so the same thing happens with the last one as well. That pattern is true every time, which means that if I want to go from that expanded form and factor it, I can do so by figuring out what two numbers add to the middle number but multiply to the last one. If I can figure out that combination, then I can write it in factored form. So one way that you could write how to factor a quadratic is like this. Now for some of you, this is the way that makes the most sense. For others of you, not as much. Go ahead and write it down though. Take a moment and write it down. And I'll give you the other way as well. And then you can choose yourself as you look back at them later. Now this is a very mathematical way of writing it. If you've been finding the work in this class to be pretty easy, you should be able to start working on wrapping your head around information that's given in this kind of a form, because this is probably stretching you a little bit more if other things have been easier. This is the way that mathematical information is often represented, where we have to choose these variables to represent pieces of equations, and then we define them. So for instance, you'll notice A, B, C, M, N here. Well, this is where those come into play. It's telling us M plus N must equal B. In other words, if I take the two numbers that end up inside the parentheses, those should add to be the B value. That is the middle number up there. That's what this really means.
Can you say that again?
Similarly, for this last one, there it says M times N, right? So M times N. In other words, if I multiply the two numbers that are inside of the parentheses, that should give me the last number in my quadratic up here. So it's just a very symbolic way of representing that. But of course, sometimes the symbolic representation is tough. And if that's the case, then you might prefer to just write it down this way. This is saying the same kind of an idea. It's just not as technically correct, but it's still going to help you remember. So if that last one didn't make sense to you, write this down, because this will make more sense to you later as you look at it. We're going to practice this idea with this problem first. So there's really just one question we have to answer in order to be able to factor this. And that is, what two numbers add to a positive 13? And so we're just adding to the 13 there. And what two numbers multiply to give me negative 30? You notice that the sign that's in front of the number goes with it. Now some of you, you know those two numbers right now off the top of your head. And if that's the case, good. But if you don't, what do you do? Because a lot of these, and I think this one probably too, you're probably going to tend to look at it and know what the answer is pretty quickly. But for others, you're not going to see it right away. So what do you do if you don't see it? A method that will always work is you could actually write out a table. Now I'm going to go through this fairly quickly. This is mostly head knowledge that you're doing. Just kind of stuff you're going to be doing in your head, but you can also write it out to make sure you've accounted for everything. Basically what you want to do is you want to figure out what is every possible way you can multiply to the last number. And so that's what you see listed out there. Those are all of the different ways that we can multiply to a negative 30. In one of those combinations then, we must have our solution. Now, in order to figure out which one, I go ahead and I add those numbers. Like negative 1 plus 30 is 29. And negative 2 plus 50. We just keep going down the list and adding them all up together. Now, the nice part is, you probably don't have to go through too many before you find your answer. Because you'll notice here, remember we're trying to figure out which two multiply to negative 30. Okay, that's that whole left column. But add to 13. You see the answer? It's the negative 2 and the 15. And so then we write our answer as parentheses, x minus 2 times parentheses x plus 15. Whatever those two numbers are, they're the ones that go inside the parentheses. Now notice, if it's a negative number, it becomes a minus inside the parentheses. If it's positive, then we add. All right, so from there, a few little detail-y things. The order that you write the parentheses in doesn't actually matter. So you actually could have also written this answer as x plus 15 times x minus 2. That would still give us the exact same thing. The order of the parentheses does not matter, but what does matter is what's inside. So for instance, you notice plus 15, plus 15. The sign on that number should not change. So the stuff inside the parentheses, it does stay the same. Now, for those of you who just looked at this right away and said, oh yeah, I know those two numbers. It's negative 2 and 15. Good. You didn't have to make the table, and most of the time you won't need to make a table for these. The table is just the fallback. Most of the time, I hope that you're just going to look at it and know those two numbers and go straight to your answer. The table I'm giving you in this problem, and it's the only time I'm going to do it for you, is just showing you the technique of what do you do when you get totally stuck. Because if you get totally stuck, you got to go through it systematically. That is, don't just start jumping around. This is also why knowing your times table is going to help you immensely. Because oftentimes you'll be able to do a mental search of your times table and find that combination. All right, I just want us to practice those ideas now. So please go ahead and factor each of these four using that same method. So for that first one, you're looking to say what two numbers add to 9 multiply to 20. Now you've seen a lot of those add to multiply to problems in the past. This is why you've seen so many. They're getting you ready for this. Hopefully you figured out. Focus first on the multiplying. So think of what two numbers multiply to 20 and then see if they add to 9. Hopefully you came up with 5 and 4. And so then it would be x plus 5 times x plus 4. Now if we go to the right from there and take a look at this one next, x squared plus x minus 20. What are we adding to in this problem? So the number we add to is always that number that's in front of x. And so in this case, when we write just x, remember that is the same, yes, as 1x. And so in that case, you're adding to 1 and multiplying to negative 20. All right, so taking a look at how we then would find that combination of numbers. Something to note is always the signs of what you multiply to. So like notice in this problem I have to multiply to a negative 20. That tells me that when I go and write these out, and oftentimes writing out the parentheses with the x's in there at the start is a good idea. When I write them out, in order to multiply to a negative, I have to have both a positive and a negative number. And then it's a matter of, again, thinking, okay, now what multiplies to 20? Well, we already saw 5 and 4. But notice that if I use 5 and 4 again, because one of them has to be negative, I can add to 1. In fact, we can get if we make the 5 the positive and the 4 the negative. As you look at these, if you're trying to decide, okay, which one should be positive, which one should be negative, then remember that whichever one you have more of when you add them, that'll be the sign of your final answer. So since I have 5 positives and 4 negatives, I have more positives than negatives, therefore I get a positive 1. All right, then we jump down to the bottom row here. If I'm going to be multiplying to 10, well, the first combination that jumps out to me is 5 and 2, but we tend to get locked into a positive 5 and a positive 2 because we're multiplying to a positive 10. But remember, that's not the only way to multiply to positive 10. You could also multiply a negative by a negative, which will then allow you to add to negative 7. And so then that's our answer for that one. And then for the last one, again, thinking about what your signs will be. If you're going to multiply to a negative, that means you have to have one positive, one negative. If we're going to add to a negative, that means I have to have more negatives than positive. And so there's your final answer for that last one. Each of those are factored. You'll often hear it also described as written in factored form or something similar to that. And then having done these, there are a few little things that come up along the way, though, that can sometimes trip us up. I'm calling these the special cases. So I want to take a look at each of these 4 problems and see what we would do to handle those. So the first one, x squared minus 25. Write down the problem so you can write down the answer when we get there. I see the x squared there. So that's already making me think that maybe I'm going to end up with this kind of a form again. And yes, we will, because I'm continuing the same theme as today. But in this case, the minus 25, is that what I'm going to add to or multiply to? Well, does it have the x attached to it? No. And remember, the middle number is the one that has the x on it. So that must mean this is like the last number. So I'm actually multiplying to the negative 25. Okay, well then what am I adding to? Well, there is no x term, right? So if that x term totally goes away, that must mean that it was a 0x. So in this case, you're adding to 0 and multiplying to negative 25. Well, what 2 numbers do that? Well, to multiply 25, I could do 25 and 1, but I'm not going to get a 0 out of that. What about 5 and 5, right? But in order for it to add to 0, doesn't one of them have to be negative? And the other one is positive. And so we end up with a negative 5 and a positive 5 there. So x minus 5, x plus 5. Because notice, negative 5 plus 5 is 0. And negative 5 times 5 is the negative 25. And that's what we're looking for in that situation. So the only way that that middle term will disappear is if both numbers are the same, except that one is added and the other one subtracted. All right, the next one, over. So our x squared plus 8x. How would I factor that one? Well, after today's lesson, we can easily make it more complicated than it really needs to be. This one was almost easier before we did today's lesson. I just don't want you to forget about it. Because what can I factor out of both terms? X. So I can still do that. I can still start by just factoring in x out of both terms. And so x squared divided by x is x, plus, and then 8x divided by x is 8. So you still need to look for, can I divide each term by the same thing? In this case we can, and so we do, and then we're done. We don't need to do anything else. Having seen those top two, you notice the bottom two are both very similar. So go ahead and now factor the bottom two on your own.